Good morning, all of you. Today we'll start chapter 1, that is electric charges and fields. This chapter contains 5 marks in your CBSE syllabus. So before starting, we should know what is electrostatic and what is electric charge. We will start this chapter. So what is electrostatic? You know that static means at rest. Static means at rest. So what is electrostatic? So I can define it is the branch of physics which deals with the study of electrical behavior of charge at rest. So electrostatic means it is the branch of physics which deals with the study of electrical behavior of charge at rest. So let's explain what is charge. Charge concept comes from atom. You have already read what is charge in 10th class. So what is charge? So charge can be defined in this way. Various definitions are there, but very easy trick I am saying you. Charge means it is the excess or deficiency of electrons occurs on a body. So I can say the excess or deficiency of electrons occurs on a body. Excess electron means I can give an example how we can define charge. Suppose we will take two body. Let one body is glass rod, another body is silk materials. So if we will rubbing by the process of friction, you have read in 11th class, by process of rubbing means a glass rod is rubbed upon silk material and a silk material is rubbed upon glass rod. Then what happen? Electron will be exchanged. Means by rubbing this glass rod and silk material, glass rod becomes positive charge, whereas silk material become negative charge. How glass rod become positive charge? By giving electron to the silk material. Means here positive charge means donate electron. Negative charge means accept electron. So silk material accept electron from the glass rod, where glass rod is giving electron to the silk material becomes positive charge, and silk material giving electron to the glass rod becomes negative charge. So I can define charge are of two types. One is positive charge, another is negative charge. Positive charge means I can say that is proton. Proton means P plus. Or negative charge means I can say electron, which is negative charge. You know that proton is having positive charge and electron which is having negative charge. So I can say mass of proton is equal to 1.67 into 10 to the power minus 27 kg, whereas mass of electron is equal to 9.1 into 10 to the power minus 31 kg. You know, I think that mass of proton, you have to remember, that is 1.67 into 10 to the power minus 27. And mass of electron is equal to 9.1 into 10 to the power minus 31 kg. And we know that charge is a scalar quantity. Scalar quantity. Scalar means only it has only magnitude. It has only magnitude but no direction. So I can define, we know that charge, or we know that I is equal to current. I means current is equal to charge by time. I means current is equal to charge by time, or you can say Q is equal to IT. That is first formula of NCERT book. Q is equal to IT. So as we know that Q is equal to I into T. So I can write unit. So how I can express what is the unit of current? You know that is ampere. Time, this is second. So, or you can say coulomb. You can mention as capital C. So what is the charge? Unit of charge, that is coulomb. And dimension formula, how I can express in terms of dimension formula? Q is equal to I means ampere, time means second. So ampere second, or you can say A1 T1. You can write A1 T1. Okay, and I can give the clear-cut idea regarding how charge is distributed. So that is unit of charge. Basically, we have read in 11th class student, charges are classified as per unit are two types. One is SI unit, another is CGS unit. So again, SI unit of charge is coulomb. C, you can mention C. CGS are classified into two types. One is ESU. ESU means electrostatic unit. Second one is EMU. EMU means electromagnetic unit. So electrostatic unit is start coulomb. EMU, electromagnetic unit, is AB coulomb. So start coulomb, how I will write in terms of coulomb, in terms of start coulomb, and coulomb in terms of AB coulomb. So we know that you have to remember 1 coulomb is equal to 3 into 10 to the power 9 start coulomb. Clear, students? Next, 1 coulomb is equal to 10 AB coulomb. You have to remember the relation. Clear? This is the relation. 1 coulomb is equal to 3 into 10 to the power 9 start coulomb, or 1 coulomb is equal to 10 AB coulomb. You can say 1 AB coulomb is equal to 1 by 10 coulomb. Like that, 1 start coulomb is equal to 1 by 3 into 10 to the power 9 coulomb. Like this you can express. Okay? Next is we will read about the properties of charges. Property, this is very important as for exam point of view, students. Properties of charge. The first property is charge is additive in nature. Charge is additive in nature. Additive in nature means I will provide total charge Q amount of charge. Means I will give Q amount of charge upon a body. Then additive nature means the total charge is equal to summation of individual body's charge. Let n number of body are there. Body parts are there. Means I can say capital Q is equal to summation of Q1 plus Q2 up to Qn. So how I can express it in summation form? Summation I start from 1 to n Qi, where I is equal to 1. So Q1 plus Q2 up to Qn. So this is the expression. Okay, second properties. Second property is very important properties. Charge is conserved in nature. Conserved in nature. The conservation of charge, this term is very important. Conservation of charge means charge can neither be created, charge can neither be created nor be destroyed, but it can transfer from one system to another system. So again I will explain. Charge can neither be created nor be destroyed, but it can transfer from one system to another system. So I can say for an isolated system, means single system, isolated body or isolated system, the charge will remain constant or conserved. Next properties, that is very important properties, that is charge is quantized in nature. This is very important, students. Quantization of charge in your CBSE board exam, this is one of the important questions. Quantization of charge. Quantization of charge means I can say it is defined as the total charge. Total charge is the integral multiple of basic amount of charges. So what is the meaning of this sentence? Total charge is the integral multiple of basic amount of charges. Means suppose I will consider a body contain Q amount of charge. So Q is equal to integral. Integral means integral is depend upon the number of electrons present inside the body. So Q is equal to integral means n basic amount of charge we are considering, that is small e. So Q is equal to, I can say, Ne, where n is the number of electron and E is the basic amount of charge. Clear? And the basic amount of charge E value is 1.6 into 10 to the power minus 19 coulomb. You have to remember this value. Many times we will use this value. E is equal to 1.6 into 10 to the power minus 19 coulomb. Clear? So quantized means I can say easily one word, that is continuous. If discontinuous term is there, means not quantized. So continuous means the total charge. Suppose let the body contain, suppose I am consider a body having one charge or one electron, that is one number E. Then the charge is equal to Q is equal to E. Okay, suppose I will provide two number of charge means Q is equal to n. In place of n you will write 2. Like that, n number means Q is equal to n. We will consider like this. Okay, this is very important point. Next, fourth properties, you know that very easy properties. Like charges like charges are repel. Like charges are repel to each other. Repel to each other. And unlike charges are attract to each other. Means, we will consider like charges. Means, suppose plus q and plus q, or minus q minus q. These are the two like charges. So they are repelled to each other. Repulsion means repulsive force between these two charges. Like charges are repelled to each other. Suppose I am considering unlike. Suppose one body contains plus q charge, another body contains minus q charge. Means there should be attractive force. That is one attractive force between two body. Or you can interchange also, minus body having minus q charges, another body having plus q charges. Same attractive force will created between two body. Clear? So I can say like charges are repelled to each other, unlike charges are attract to each other. Next point, charge is transformable in nature. Charge is transformable in nature. Transformable means, suppose one body having body A, another body B. So the charge can transfer. If you will contaminate or if you will keep contact between two body, then the body charge can be transferred from A to B or B to A. Like that, charge is transformable in nature. Next, 6 point, charge cannot vary with respect to speed. Charge cannot vary with respect to speed. If body speed means body velocity is there, means charge cannot vary. Charge will remain same if body is movable. For moving body, charge cannot be changed. Next point, charge, this is very important point. Charge cannot exist without mass. Means charge having a small mass, that is basic amount of mass E, that is the value is 1.6 into 10 to the power minus 19 coulomb. But I can say mass can exist with charge. Mass can exist without charge. Without charge, mass can exist. Suppose this is the body having mass M. So this body or this body having without charge. But charge cannot exist without mass. Minimum mass is equal to 1.6 into 10 to the power minus 19 coulomb should be there. Next we will start, that is very important, Coulomb's law of electrostatic. Later on we will do problem is there related to quantization of charge in your NCERT book, but theory we will complete in this section, that is Coulomb's law of electrostatic. Coulomb's law of electrostatic. Coulomb's law. This is very important point. Exam point of view, student, this is very important. Coulomb's law of electrostatic. What is Coulomb's law? I will explain, then I will write the definition. Suppose two stationary charges are there. Let one stationary charge having Q1, another stationary charge having Q2, and the distance between two stationary charges is A. and the position of the stationary charge is A and B. So there is a force of attraction or repulsion. I can say if this is two positive charge, then force of repulsion. If this is two negative charge, also force of repulsion. Positive negative charge means force of attraction. So how I can define Coulomb's law of electrostatic? Means I can say the force of attraction or the force of repulsion between two stationary point charges is directly proportional to the product of charge. So I can say force is directly proportional to the magnitude of product of two charges Q1, Q2, and it is inversely proportional to the square of distance of separation between them. So I can say 1 by r square. So F is proportional to Q1, Q2 by r square. So that implies F is equal to K into Q1, Q2 by r square. This is the formula at equation number 1. K is the proportionality constant. Remember that K is the proportionality constant. So how I can express it? It state that the force of attraction or repulsion between two stationary point charges is directly, whatever the definition I have written, this is the definition, this is the formula. Force is directly proportional to the force of attraction or repulsion between two stationary point charge is directly proportional to the product of charges and inversely proportional to the square of distance of separation between them. So I can say F is directly proportional to magnitude of product of two charges and inversely proportional to the square of distance of separation between them. Then F is proportional to Q1 Q2 by r square. So F is equal to K Q1 Q2 by r square, where K is equal to 1 by 4 pi epsilon 0. And the value is proportionality constant value is constant, that is 9 into 10 to the power 9 Newton meter square Coulomb inverse 2. How the unit comes, I will later explain. So I can write this value, I can put here. So F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by r square. So we can say this is equation number 2. Clear, student? Then from this is very important expression. From this expression you can calculate whatever you want. Means what is epsilon 0? Epsilon 0 is the permittivity in free space or air medium you can write. So I can say permittivity, the value is, you remember that value 8 point, how it will come I will explain later. 8.85 into 10 to the power minus 12 Newton inverse meter inverse to Coulomb square. How this value comes I will explain later. Clear? So I can say every value, you know that F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by r square. So what is next? What is relative permittivity? Relative permittivity. This is very important. Permittivity. So relative permittivity means that difference between two medium, or you can say permittivity of medium. You can explain relative permittivity or permittivity of medium. Better you can write permittivity of medium. Okay, so relativity permittivity will take later. So what is permittivity of medium? Permittivity medium means epsilon 0 means permittivity in free space. Okay, the permittivity in medium means difference between two medium in the presence of electric field. What is electric field? I will teach in next class of the video. So permittivity of medium means difference between two medium. So difference between two medium means, suppose I will take one air medium, another water medium. What is the difference between two medium in presence of electric field? Suppose I will provide electric field, then what is the difference between air medium and water medium? So that is the permittivity of medium. And we will remember one formula, that is very important formula. Epsilon is equal to epsilon naught into epsilon r. Epsilon is the permittivity of medium. Epsilon 0 is the permittivity in free space. Epsilon r is the relative permittivity. So epsilon r is equal to, I can say, epsilon by epsilon 0. Understood? Epsilon r is the relative permittivity. Epsilon is permittivity in free space divided by permittivity in any medium. Clear? So I can define absolute or relative permittivity is equal to permittivity in any medium. Permittivity in any medium divided by permittivity in free space. In air, you can write permittivity in air. Permittivity in any medium divided by permittivity in air. Okay, so how we will write the formula? So basic formula is F is equal to K into Q1 Q2 by R square. We have derived in previous page. Okay, so how I will explain K? K is the proportionality constant. So in this equation, K is equal to, solve it, FR square by Q1 Q2. So what is the unit of K? Unit of K. So F, what is the unit? Force, Newton. Distance square means meter square. Q1 Q2 means Coulomb square. So I can say Newton meter square Coulomb square. That's why the value I have written K is equal to Coulomb inverse 2. Coulomb inverse 2, that is 9 into 10 to the power 9 Newton meter square Coulomb inverse 2. And epsilon 0. How I will put epsilon 0? See, we know that F is equal to 1 by 4 pi epsilon 0 into Q1 Q2 by R square. This is K. So I can say K is equal to 1 by 4 pi epsilon 0. Solve it. So epsilon 0 is equal to 1 by 4 pi K. So epsilon 0 is equal to 1 by 4 pi means, you know that 3.14. K is 9 into 10 to the power 9. If you will solve, you will get epsilon 0 is equal to solve it, then 8.85 into 10 to the power minus 12, unit is 1 by this. So Newton 4 pi is a constant quantity, so K value is Newton meter square coulomb minus 2. And if you will go to numerator, this Newton become Newton inverse, meter become meter minus 2, coulomb square. So that is the value we have remember this value. Okay, so next class, how to solve problem related to Coulomb's law and problem related to quantization of charge. In my next video, we will read how to solve problem related to this. Thank you.